So now today we are going to discuss about the tangent to the circle for class 10 CBSE, right? So this is very important question chapter for CBSE board examination class 12, tangent to the circle. Now first of all we need to discuss about the tangent. And you know, tangent and secant are two parts in a circle. If we draw a circle here, let's see if this is a circle. So we can draw two different straight lines in the circle. One straight line we can draw like this, which touches the circle at a point. And this type of line is called the tangent to the circle. Which line touches to the circle at a single point, right? But if a line cutting the circle at any 2 points, this type of line is called secant, right? This is called secant because this line is intersecting the circle at any 2 points. You can draw any line which intersect at 2 points. You can draw any line which intersect at 2 points. That is called the secant. But tangent touches the circle at a single point. Tangent touches the circle at a single point, which is called the tangent, right? Now let's see. If we will discuss about the tangent, so we can say in a circle we can draw infinite tangents in a circle, because in a circle on the circumference we have infinite points. So from every point we can draw a tangent. From every point we can draw a tangent. For example, if we have this circle and we need to draw a tangent, so how can we draw? From this point we can draw a tangent. From this point we can draw another tangent. From every point we can draw a tangent. So we can say in a circle we can draw infinite tangents in a circle, because there are infinite points on the circumference, and from each and every point we can draw a tangent. So if point of contact of circle is given, we can draw one and only one tangent. So we can draw one and only one tangent at a single point of contact. Let's see, P is the point of contact, so we can draw one and only one tangent from this point of contact, right? Now, let's see about the two circles. If we have two circles, how many tangents can be drawn from two circles? Now, it's depend on the position of the circles. It depends on the position of the circle. If we have two circles like this, a circle and second one is concentric circle, how many common tangents can be drawn? How many common tangents can be drawn from these two concentric circles? No common tangent can be drawn. No common tangent. We cannot draw a tangent which touches this circle as well as this circle, because both circles are concentric. So, how many tangents can be drawn from two circles? How many common tangents can be drawn? It depends on the position of the circle. If we have two circles like this, a circle and another circle inside it. If we have two circles like this, let's see, the small circle just touches the bigger circle at a point. So we can draw a common tangent here. We can draw a common tangent here, but we cannot draw common tangent in this type of two circles. In this representation, we can draw one and only one circle. Yeah, we can draw one and only one tangent in this also. If we have this type of, how many tangents can be drawn from these two circles? 3. First tangent. We are talking about the common tangent. First, this one is the common tangent. Secondly, we can draw this line also. This is the tangent, common tangent from these two circles. We can draw like this also. So we can draw 3 different circles here, 3 different tangents here from these two combination of circles. So it depends on circle position how many tangents can be drawn. Here we cannot draw any tangent. Here we can draw one tangent. Here we can draw three tangents. If a circle, these type of two circles are there, we can draw only two tangents. Right? Two tangents are there. It depends on the position of the circle. Right? Very good. So now these are about the basic concept of the tangent. Now you can do the question related to basic of the tangent. Now we will discuss some theorem related to the tangent to the circle. So now we have some very important theorems. We have some very important theorems. We have only two theorems in this chapter. You know, in class 9th you have many theorems in the circles, but in class 10th we have only two theorems. Theorem 1, the tangent is perpendicular to the radius of the circle passing through the point of contact of the tangent. Point of contact of the tangent. The tangent is perpendicular to the radius of the circle passing through the point of contact of the tangent. So we are talking about the tangent and the radius. Which radius? That radius is passing through the point of contact to the tangent. Right? So first of all we need to draw a circle. We need to draw a circle here. This is a circle. Let's see. This is a circle, and let's consider, and this is the point of contact. Let's consider this is the point of contact. This is the point of contact P. Right? So here we considered a circle, and we are talking about the radius. There are infinite number of radius can be drawn in this circle, but we are talking about the radius which passing through the point of contact, right? So we are talking about this line, right? Now let's see, AB is a tangent and OP is the radius. Because we are talking about this radius only, which passing through the point of contact. So we need to prove this OP line is perpendicular to AB line, right? Very good. Now we can write this theorem as let COR be a circle. Let COR be a circle. What do you mean by COR? C for circle with center O and radius R. C for circle with center O and radius R. We can write let COR be a circle in which AB is a tangent passing through the point of contact P. Passing through the point of contact P. Right? This is a circle with center O and radius R, and this tangent AB is passing through the point of contact P. Now, what we need to prove? We need to prove OP is perpendicular to AB. We need to prove OP is perpendicular to AB, right? So now how can we prove OP is perpendicular to AB? We need to construct something in this. We can take some point Q, R, S on the tangent. We can take some points, we can take any number of points, we can take 2 point, 3 point, 4 point, 5 point. We need to consider some points on the tangent AB. So here in construction we can write some points Q, R, S taken on tangent AB. AB. So we consider some point. Now join OQ, OR and OS. Now we can join these lines. So in dotted lines we can join OQ, we can join OR, we can join OS, right? And which intersect the circle at point M, at point N, at point L. Which intersect the circle at point M, N, L respectively, right? So if you joining O with Q, O with R, O with S, which intersect at M and L. Now we can say OM is the radius. We can say OM is the radius, OP is the radius, ON is the radius, OL is the radius. So these are the radii. OM, OP, OL and OM. These are the radii. So in proof we can write since OM is equal to OP is equal to ON is equal to OL. These are equal to radius of the circle, right? Now, so we need to prove OP is perpendicular to AB. How can we prove this? Now we can say if from any point you draw some line segment on this line. From any point outside the line, if you draw some lines, so the shortest line must be perpendicular to this line. This is called the shortest line, and shortest line must be perpendicular to this line. So we need to prove here OP is the shortest. So here we can say OQ is greater than radius, OR is greater than radius, OS is greater than radius, but OP is equal to radius. So we can say OP is the smallest one, right? So here we can say OQ is greater than radius, OR, from diagram we can say OR is greater than radius, OS is greater than radius. So OQ, OR and OS are greater than radius. Why? Because OM, ON, OL is equal to the radius. So therefore we can say OP is less than OQ, OP is less than OR, OP is less than OS. So therefore OP is the smallest one, is the smallest. So here we can say OP is the smallest, right? OP is the smallest. So from any point to this line, if a line is smallest one, so we can say this line will be the perpendicular on AB. So therefore OP must be perpendicular to AB. This we need to prove in this question. So this is our first theorem. Theorem is what? The tangent to the circle, it must be perpendicular to the radius. Which radius? Which passing through the point of contact on the tangent. This is very first theorem, very important theorem. There are only two theorems. Now we can also prove the converse theorem of this. What will be the converse theorem? If you join a point from P to center, point of contact to the center, this must be perpendicular. Otherwise, you can draw a straight line which is perpendicular to the radius. This must be the tangent. That straight line must be the tangent, right? So this will be the converse theorem. Now we will do some different question based on this theorem. So first of all, we need to discuss the second theorem. After solving these two theorems, we will discuss some question. What type of question can be asked in this chapter, right? So now the second theorem is very simple. Second theorem is also based on the tangent, and the theorem is theorem 2 is exterior point the from an exterior point on the circle, the length of two tangents to the circle, from an exterior point the length of two tangents to the circle are equal. Means if we draw a circle here, let's say this is the circle. So in this circle, if we have an exterior point P, if we have a circle with center O and radius R and an exterior point P, so first of all, how many tangents can be drawn? How many tangents can be drawn from the point P to this circle? How many tangents can be drawn? So we can say we can draw only two tangents. We can draw only two tangents which passing through the point P, which is exterior to the circle. So the question is, in a circle, if you have the point outside the circle, how many tangents can be drawn? So we can draw two tangents, right? And the question is, the length of both the tangents are equal. So we need to prove both the tangents are equal. So let's see, what are the tangents here? Yeah, this one is the tangent and this one is the second tangent. We can draw two tangents with point of contact A and B. So we need to prove PA is equal to PB. So we can write the statement as let COR be a circle. Let COR be a circle in which a point P is outside the circle. Two tangents PA and PB are drawn. Two tangents PA and PB are drawn. Two tangents PA and PB are drawn. So we need to prove here, we need to prove both the tangents are equal. We need to prove length of PA is equal to the length of PB. We need to prove both the tangents are equal in length. So we have to prove PA is equal to PB, right? Now how can you say that PA is equal to PB? I think we can use the property 1 here. We have some construction here. So what type of construction? We can join the center with point O and we can join the center with point B. What are the benefit to join this? We can say OB is perpendicular to PB and OA is perpendicular to PA. Why? Because of theorem 1. Theorem 1 said that a tangent must be the perpendicular to the radius. So we can say OA is perpendicular to PA and OB is perpendicular to PB. Right? And again join OP. Why we join this one? The objective to join OP is to make two triangles. And we need to prove PA equal to PB. So we need to prove this triangle is congruent to this triangle. If both triangles are congruent, so we can say by CPCT PA is equal to PB. It's very simple. Now, in construction we can write, join OA, OB and OP. Now proof. We need to prove both triangles are congruent. So in triangle POA and triangle POB. In both the triangles, we can say this is perpendicular by property 1, by theorem 1. And in both the right angle triangle, we can say hypotenuse are same. This is the common part, right? Opposite side of the right angle is called hypotenuse. Opposite side of right angle is called hypotenuse. So hypotenuse OP and OP are same, and OA and OB both are radii to this circle. So we can apply right hypotenuse side property to get these two triangles are congruent. So first of all we need to write OA is equal, we can write the angles as 90 degrees. So we can say angle OAP is equal to angle OBP is equal to 90 degree. Why this is 90 degree? By theorem 1. You have to write the complete theorem in this. Theorem 1, right? Secondly, OP is equal to OP. These are the common side. And third, we can say OA is equal to OB, which is equal to the radius. So, by RHS congruency, we can say triangle POA is congruent to triangle POB. So now we can say both the triangles are congruent. Triangle POA is congruent to triangle POB. Both the triangles are congruent. So if both triangles are congruent, then by CPCT, you know about CPCT? Corresponding part of the congruent triangles are also equal. Corresponding part of the congruent triangle, we can say PA is equal to PB. So these two tangents are always equal. Very simple question and very important. In a circle, if you have some complicated figure in triangle, quadrilateral, pentagon, so you have to think about, is there any exterior point to the circle? Yes. If you have some exterior point in the circle, you can say the tangent drawn from that exterior point are always equal. Right? Very important. Now, so these are two very important theorems in this chapter. Now we'll discuss some basic question related to this topic, tangent to the circle. Let's see. If we have a question like, if we have a circle and center given, if we have an exterior point P and the question is the length of tangent to this exterior point PA is equal to 4 centimeter and the exterior point to the center is 5 centimeter. So what is the radius of this circle? Very simple question for 1 mark. In a circle, the length of tangent is 4 centimeter and the length of center to the exterior point is 5 centimeter. So what will be the radius? What is the length of the radius? Right? So we have to find the length of the radius here. So we can use the property, we can draw some construction, we can draw O with A. If you draw O with A, you can say OA is perpendicular to PA. Why? Because of first theorem. First theorem said that tangent is perpendicular to the radius. By drawing OA, by joining OA, we will get a right angle triangle. Why? Now we can say OA is perpendicular to PA. Now you can say PA is equal to 4 centimeter, which is given, and PO is equal to 5 centimeter. So we can apply Pythagoras theorem to find the radius. We can apply the Pythagoras theorem to find the radius, right? So now we have to find the radius. We can use the Pythagoras theorem. We can say the opposite side of right angle is called hypotenuse. So this one is called hypotenuse. So we can say by Pythagoras theorem, OP square is equal to AP square plus OA square. So OP square we can put 5 square is equal to AP square 4 square and plus OA square, which is equal to the radius. We can say 25 minus 16 is equal to R square. So R square is equal to 9. So therefore radius is equal to 3 centimeter. If you have R square equal to 9, so we can say R is equal to plus minus 3, but we cannot consider the minus 3 because radius is the length which cannot be negative. So radius is equal to what? 3 centimeter in this, right? So now we will discuss some more questions in the next tutorial related to tangent to the circle and radius to the circle and these two theorems, right? Thank you so much.